In this video, we are going to explain about a project titled Detection of Possible Illicit Messages using Natural Language Processing and Computer Vision on Twitter and linked websites. So now coming to the introduction part, developing an effective detection system poses various challenges such as dealing with contextual nuances, ambiguous language, and the rapid evolution of communication patterns on social media. Researchers and developers must continually refine and update the algorithms to stay ahead of emerging illicit tactics and adapt to the dynamic nature of online communication. Nevertheless, the ongoing efforts to enhance the accuracy and efficiency of this technology underscore its significance in addressing the ever-growing concern of illicit messages on social media and linked websites. With further advancements and improvements, this integration of NLP and computer vision holds the promise of creating a safer and more secure online space for users worldwide. The application of sentiment analysis, text classification, and language modeling helps in identifying patterns that might indicate illicit intent, hate speech, cyberbullying, or any form of harmful communication. The incorporation of computer vision techniques allows the system to analyze images and videos shared on Twitter and other linked websites, providing an additional layer of insight to detect potentially inappropriate or harmful content. So now coming to the objective part for this project is to create a safer and more secure online environment for users of social media platforms and linked websites. By automating the detection of potential threats and illicit messages, the system can support the efforts of social media companies in enforcing community guidelines and promoting responsible online behavior. Additionally, it can aid law enforcement agencies in identifying and addressing illegal activities, contributing to the overall well-being of online communities and protecting individuals from the adverse effects of harmful content. By analyzing visual data, including images and videos, the technology aims to identify and flag multimedia content that may be associated with illicit activities, violent behavior, or harmful propaganda. This further enhances the system's ability to identify and prevent the spread of harmful content across diverse media formats. So now coming to the requirements part, we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, first operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDE that is 3.7 version is required. So now coming to the methodology part, first input hashing. Input hashtag in the process involves selecting and providing a specific hashtag as the input. A hashtag is a keyword or phrase preceded by the hash symbol and is commonly used on social media platforms like Twitter to categorize and label posts related to a particular topic or theme. Second, online crawl Twitter. After specifying the hashtag, the system begins online crawling, which involves collecting tweets that involve the chosen hashtag from the Twitter's live stream in real time. Third, offline upload Twitter dataset. Once a substantial amount of tweets is gathered through online crawling, the dataset is stored offline for further processing. The offline upload ensures that the system can handle and analyze the data for efficiently, as it removes the need for continuous online data retrieval. Fourth, clean tweets and extract features. Before performing an analysis, the collected tweets undergo a cleaning process to remove any noise, irrelevant information, or special characters that might hinder the accuracy of the subsequent analysis. After cleaning, essential features are extracted from the tweets. These features may include the text content of the tweet, user metadata, timestamp, and other relevant information. Fifth, suspicious tweets classification using SVM and naive. With the cleaned and pre-processed dataset, the system employs machine learning algorithms, specifically support vector machine and naive-based algorithms, to classify tweets into suspicious or non-suspicious categories. The algorithms are trained on labeled data where tweets are manually marked as suspicious or not, and then applied to the entire dataset to predict the classification of unseen tweets. Sixth, SVM and CNN classification for gender and age prediction. In this step, the system expands its capabilities beyond detecting suspicious tweets. It utilizes both SVM and CNN to predict the gender and age of Twitter users based on their tweets and user profile information. SVM is a traditional machine learning algorithm, while CNN is a deep learning model specifically designed for image such as text. 7th, extension SVM and naive based with PSO features optimization. To improve the accuracy and efficiency of the initial SVM and naive based classifiers, the system extends the models by incorporating particle swarm optimization, that is PSO. It is a meta-heuristic optimization algorithm inspired by social behavior. It aims to find the best combination of features for the classifiers, optimizing their performance and enhancing the quality of tweet classification results. 8th, comparison graph. To evaluate the performance of various models and approaches used in the analysis, a comparison graph is generated. This graph visually represents the accuracy, precision, recall, and other relevant metrics of each model, allowing for a straightforward comparison of their effectiveness in detecting suspicious tweets, predicting gender and age. 9th, extension comparison graph. The final step involves extending the comparison graph to incorporate the results to obtain the extended models that include PSO features optimization. This comparison allows for a comprehensive evaluation of the entire detection and prediction pipeline, highlighting the contributions and enhancement brought about by the PSO-driven optimization approach. So now coming to the execution part. To execute the project, first we need to open the code folder. So here we have a folder named as dataset. Here we have a dataset, that is .csv extension. And here we have a folder with the name model. So here we have some PK files, PKL files, and XML documents, and also binary proto files. This is our main Python file, which is containing the Python script area. And this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file to execute the project. This is the graphical user interface with this we are interacting with the program. So now here I have to put an input, that is I'm putting over here lol82. And now click on online crawl Twitter. After that, click on offline upload Twitter dataset and select the dataset and click on open button to upload the dataset. Now click on clean tweets and extract features. So now here we can see each raw tweets that get processed for cleaning, and now clean tweets are ready. And to detect suspicious words, like click on suspicious tweets classification using SVM and naive Bayes button to apply SVM and naive Bayes on each tweet to get suspicious words. So now here we can see displaying each cleaned tweets, and after equal to symbol displaying detected results as contain suspicious words or not. Now we have tweets which contain suspicious words, and now we have to click on SVM and CNN classification for gender and age prediction button to scrape each tweet's websites to read image and to predict the age and gender from images. So here we have in this screen that got application detected face, and then displaying female under 14 years, and application repeats above steps for all tweets, and below see another image. Now here we can close this image and it will generate a new image. So here we can see the result of another image. So it will generate another image again and again over here by closing these images. So now click on comparison graph button for getting the graph. Here x-axis represents precision, recall and F-score, and y-axis represents its values. So from this graph we can conclude that SVM is giving better accuracy. And so now closing this graph, click on extension comparison graph. So now in this graph, we can see that x-axis represents algorithm names and y-axis represents precision, and in all algorithms with PSO giving better precision. So now closing this graph, coming back to the conclusion part, looking forward, continuous collaboration between academia, industry and regulatory bodies is essential to further enhance the capabilities of the detection system. Advancements in machine learning, data privacy and user content mechanisms will undoubtedly play a crucial role in shaping the future of this technology. By fostering responsible AI development and ethical deployment, we can ensure that the detection of possible illicit messages using natural language processing and computer vision on Twitter and linked websites contributes positively to a safer and more inclusive digital landscape for all users. By aiding social media companies in enforcing community guidelines and policies, the system can contribute to the creation of a healthier online ecosystem that encourages responsible and respectful communication. Additionally, by assisting law enforcement agencies in identifying and responding to potential threats and unlawful activities, this technology becomes an essential tool in maintaining law and order in the digital realm.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.